Good morning, all of you. So today, already in laws of refraction, I told you sin I by sin r is refractive index, and in terms of velocity, wavelength, and frequency, also whatever it is formula we have learned. Okay, because frequency remains constant uh, in the refraction. So today, again, I am telling you what is this Snell's law. So see. If you want statement, then can I say like this? Ratio of sine of angle of incidence to the ratio of sine of angle of refraction is always constant. What is that? A ratio of sine of angle of incidence to the sine of angle of refraction is the refractive index of the medium, or is constant, you can say, is constant. Called refractive index of medium. Okay, so that is sine I divided by sine r is equal to constant, and that is equal to mu. So let's see one example, then you will understand better. So example, suppose now this is medium 1 and this is medium 2. And light we have incident from here. Then this ray will refract like this. And let us suppose this is normal here. Okay, so here this angle is angle of refraction because this is a normal, and this angle is angle of incidence. So this one is medium 1 and this one is medium 2. So let us suppose the refractive index of this is mu 2 and for this it is mu 1, and this is the light ray. So here in this case what you will get, mu 1 sine of I is equal to mu 2 sine of r. Therefore sine of I divided by sine of r is equal to mu 2 by mu 1. Even you can write it as a mu 2 1. What is mu 2 1? Here mu 2 1 is refractive index of second medium with respect to first. Okay, this is what your Snell's law is. You can keep it in mind. Okay, so ratio of sine of angle of incidence to the sine of angle of refraction is always constant and called refractive index of medium. That is nothing but relative refractive index of the medium. This is what your Snell's law. Okay. Next one. Is you finished? Okay, let's move ahead. So now, if suppose we want to find refractive index of material of prism, then how to find? Let's see. Now, next one, a refractive index of material of prism. Direct, I am going to give you derivation. Just try to understand how I am doing. Now let's draw the diagram first. Now here I am taking a prism. We are having one practical also on this. So in lab we will do again. And this is incident ray. Then this will refract and it will come out as an emergent ray. So let's draw two normals. So this is your first normal. You can see at this point, and here is another normal to this interface like this. Okay. This is dotted line. You keep it in mind because ray will not go here. This is just to denote actual path of the ray. So here this is angle I1, suppose. This angle I am denoting as I2, and this angle is R1. This angle is R2. Okay. And this is your normal 1. This one is normal 2. Let's give this triangle some name. So this is triangle A, B, C, which is face of the prism. And let us suppose this point is P, this point is Q, and then this one is R. This one is S for this ray. This one is, let us suppose, T, and above one is U. Okay, T and U. Here I am giving name as a T, and this one is U. Okay. So now let's start deriving this. So first one, what I am doing, from the triangle QRT, from triangle QRT, you see just this QRT. Can you see here? This Q, R and T, this triangle. So here angle R1 plus angle R2 plus angle T is equal to 180 degree. This is nothing but what? Angle of addition of all three angles is equal to 180, and therefore let us suppose this is your equation number 1. Just note it as a equation number 1. Next one, from quadrilateral AQTR, from quadrilateral AQTR. So in this AQTR, angle A plus angle T is equal to 180 degree, right? And therefore angle T is equal to 180 minus angle A. Call this as equation number 2, right? This finished. Okay. Now from equation 1 and 2, what we will get? Let's see. From equation 1 and 2, from equation 1 and 2, just what I am doing, I am substituting this T value here. So now I am not writing angle, so this is just R1 plus R2 plus this 180 minus A is equal to 180. Now this 180 and 180, when this I am transferring here, so you are getting R1 plus R2 is equal to 180 minus 180 plus A, and this is going to be cancelled. So what you are getting? R1 plus R2 is equal to A. I'm not writing angle, but it is angle only. Okay. So let us suppose this is your equation number 3. What is this? Equation number 3. Okay. Next now. From triangle QUR. Let's see now another triangle from triangle QU and R. QU and R. This upper triangle. So if we will see this angle, you see here, this will be what? I1 minus R1. I1 minus R1, है ना? Because this and this same, so I1 minus R1, if we will subtract, we will get this angle. Similarly, this angle you see, this green wala, can you see here? This one, this angle is what? I2 minus R2, I2 minus R2, this angle, right? So therefore, from triangle QUR, upper wala triangle, can I write like this? This one is 180 minus D. Okay. So let's see now what I am writing from this. I1 minus R1, I1 minus R1, this angle plus this angle. This angle is how much? I2 minus R2. Okay. Plus this angle U. Angle U. U means QUR. Okay. So let me write in this like this. QUR is equal to 180. Now angle QUR, how you will write? Angle QUR is equal to 180 minus angle delta. This is, you see, this minus this, if you will do, you will get this. So substitute here, and then we are getting I1 minus R1 plus I2 minus R2 plus 180 minus delta is equal to 180. Now this, if we will transfer here, then what we are getting? I1 minus R1 plus I2 minus R2, and this side total I am transferring that side, so 180 minus 180 plus delta, 180 minus 180 plus delta, so this will get cancelled, and you will get I1 plus I2 what we are getting, see, I1 plus this I2 minus common, and inside bracket I am writing R1 plus R2 is equal to delta. Now this R1 plus R2 is what? R1 plus R2 is what? A from equation 3. Can you see? See here, from this equation 3, R1 plus R2 is equal to A. So let's substitute here. So you are getting I1 plus I2 minus A is equal to delta, and therefore I1 plus I2 is equal to A plus delta. Right? Very simple it is, geometry just, okay. So let us suppose call this equation as equation number 4. Now this finished for I1 plus I2. For angle of minimum deviation now, for angle of minimum deviation, I1 is equal to I2, I1 is equal to I2, comma R1 is equal to R2. So therefore I1 is equal to I2 is equal to I, and R1 is equal to R2 is equal to R. Then let's substitute here what you will get now. Then equation 3 and 4 becomes what? See, equation 3 and 4 becomes like this. Equation 3, you see R plus R is equal to A. So what you can write? R plus R is equal to A. That implies R is equal to A by 2. 2R is equal to A, so R is equal to A by 2. Next one, you see this one. So I plus I here, I plus I is equal to A plus delta, and therefore 2I is equal to A plus delta. That implies I is equal to A plus delta by 2. This is what you got. Now you got I value, you got R value. Yes, R value you got here, I value you got here. So let's use now formula. So therefore refractive index of prism or material of prism we want to find. So therefore refractive index of material of prism mu is equal to sin I by sin R, and that is equal to mu is equal to sine of A plus delta by 2 divided by sine of A by 2. Just to replace that values of I and R, you will get the answer of this refractive index. Got it? Right. Understood. So let's solve one problem. One small problem, very easy. A ray of light after passing through a medium. See here how they are asking question. A ray of light ray of light after passing through a medium meets the surface separating the medium from air at an angle of 45 degree from air at an angle of 45 degree and is just not refracted and is just not refracted. What is the refractive index of the medium? What is the refractive index of medium? How to solve this problem? See now, what is the given thing here? Given. So here, can I write that angle of incidence is equal to critical angle? I is equal to C is equal to 45 degree, because you see, if you will read this question, you will just not refracted, he is saying. Just not refracted means what? Just not refracted means what? If suppose I will draw the diagram for you, you can see here, this is a light ray is coming like this and then just touching the interface, and this is what your normal is. Okay, this is what just normal. Then this angle is what yours? This angle is your angle of incidence and also your critical angle, theta c or just c, whatever you want. So if you will denote by theta c also not an issue. So this is, they have given 45 degree. So then here given thing is what? Theta critical is there, that is angle, critical angle. So let's denote it as a theta c. Okay. So here I is equal to theta c is equal to 45, and we know refractive index is what? 1 by sine of theta c. So therefore 1 by sine of 45 is equal to mu, and therefore mu is equal to 1 by 1 by root 2, which is equal to root 2, and therefore this value, how much root 2 value? 1.414. Okay, like this you will get the answer of this question. Yes or not? And this is your 90 degree. Okay, right? So please revise this and note down all these notes carefully. Let's stop here for today. Bye.